Good evening, my dear young mathematics enthusiasts. I am Sourobh Kumar Dotto and I am here to guide you people a little bit in mathematics. Now, as you people know that we are at the midst of discussing a series on indefinite integration. I hope you people are liking it all. Today, we will be discussing the irrational function that we discussed yesterday, whose derivation we discussed in detail, where I showed you how Mr. Trigonometry came over and helped out Miss Algebra, and we were able to get to the derivation result of integral of root of a square minus x squared dx. I hope with this you will be able to understand how we can use trigonometric substitutions to be able to simplify algebraic expressions which have to be integrated. Today we'll take this discussion forward and we'll be looking up a sum which is based on the same formula, and we will try and ensure that if you are a student in ISC, CBSE, IB, that is International Baccalaureate, or International GCSE, you will always be able to understand the sums which are around this. So let's get started, children, and let's discuss what this formula was and then look up a sum corresponding to it. Obviously, initially you will have to try it, and after that I'll be discussing what the solution of the sum is going to be. Now remember, children, whenever you have something like integral of root of a square minus x squared dx, I told you that x upon 2 is to be multiplied with the function like this, and to that is to be added a square upon 2 times of sine inverse of x upon a plus c. Now this you can remember as if you had integral of dx upon a square minus x square, then you actually got sine inverse x upon a plus c. So that just has to be multiplied with a square upon 2. Now, why do I tell it to you as a rule? Because we'll have 2 more formulae which will be of this type, and then you will find that again the same rule, almost this same way, is going to be applied, right? Okay, now remember that this was the derivation that we did, right? And today this is the sum before you. So initially I'll give you people a little time for trial. I'll expect that you people have tried it out really with good strength, say something like 4 to 5 minutes, and if suppose you haven't been able to, then obviously I'm there to help you out. So let's get started, children, and start trying out the sum. Yes, Abhinav. Okay, I hope you're trying, because this is the time that you're going to try out the sum, and no fooling at this time. Make sure that you are seated at a place where there is no disturbance, no friends, relatives, parents around you, and you are concentrating fully towards the completion of this sum. Now, before starting, I think you people have tried out well, and you also have practiced the derivation of this formula. If you've not, I'll request you to get back and complete that first. Okay, now children, as you see, we have the sum, right? And this looks to be a little crude because neither do we get to see sum a square nor do we get minus x square, but we will have to somehow or the other convert it in that form. So what can we do? One of the first things that we can do in this is, as this is integral of root of ax minus x square, so we find that the quadratic term is actually negative. So what you can do is you can first take the minus sign common outside, right? And then inside you will be having x square, from which is going to be subtracted ax, right? Now children, after this what do we have is we get to see that we actually have minus 1 which is within root, and as you know that this is going to be just like I, but we are not going to do that, right? We are not going to take this minus 1 root outside and make it to be I, but we'll be handling the things which are inside. You just see how. Next, now children, what we're going to do is we are again going to write these things, but now this time we're going to add up certain things more. That is, this is minus times of x square, right? Something like a square, right? And then we require the plus 2ab term. So as such, we'll be writing plus 2, and a, as we know, is x, right? So we will write it, and except that we should have something so that we can get this plus 2ab term or the linear term, right? As such, we require minus a to be the coefficient of x, and thus there has to be minus a which has to be multiplied here. But obviously as there is no 2, so that's why we have to also divide by 2. Now you get to see that the 2 will get cancelled, and minus ax will actually become the term that we require. Now you get to see that actually we have written this extra, so we also require to subtract it. And as such, here further you will now get the term which is the plus b square, right? That is the term which you'll have to remove. So you will have minus a upon 2 whole square, and from that is also subtracted minus a upon 2 whole square, because what has been added out of turn also needs to be subtracted so that the old balance can be kept back. Now next after this, as there is no more constant term, so this is all that we will be doing here, and now we will try and derive a lot of advantage out of this. There is a faceless expression on Abhinav's face and on Rani's face, so I'll rather tell you what exactly I have done here. If you talk about this x square can actually be written as some a square, right? Now if you talk about the next one, we can talk about this x to be again 2 times of a, and now if you talk about this is what? This is your b, that is minus a upon 2. Thus we are trying to target a plus b whole square. Now that we've got the value of b, right, so here in place of writing it to be minus a upon 2, I'll rather write it in the form of b so that you can understand that more. So here we've been able to find out what b is, that is minus a upon 2. So obviously here what should you have? You should actually have plus b square, and that is what we've done here, right? And as we've written this extra, so obviously we also have to subtract this, and that is why we have minus times of b square, right? So this is the method of making perfect squares. Now at this time, if you talk about the first 3 terms, they are actually trying to form the perfect square of a plus b whole square. Now to remind you people, I'll just tell you that if you talk about a plus b whole square, remember children, that's equal to a square plus b square plus 2ab, and this is what we've tried to cultivate. Okay, now if you talk about the first term thus, right, and if you talk about the second term thus, and if you talk about the third term, they are actually the expansion of a plus b whole square. So here thus now we are now going to get it in that format. As such, now in the next step you can write integral of, we will now write this to be minus, which still waits outside, and inside children we have x and minus a upon 2, and we have the whole square of this. Let's expand and quickly see. So if you talk about x squared, so we'll get this x square here. Then we'll talk about the 2ab term, which will be 2 times of x times of minus a upon 2, that is this. And then we'll be talking about the plus b square term, that is plus minus a upon 2 whole square, right? And since now we had written this extra, as such now we are also going to subtract this. As such we have minus a upon 2 whole square children, and with this is multiplied the differential coefficient. I hope all of you people have now been able to understand. Okay, there is partial understanding among the group of children that I have. So in the second explanation in times to come, you will get to see that you will get more clarity, and that is why I tell you that don't pick up your writing material till the time we do our second explanation, because that is the time when maximum amount of clarity actually blossoms in your brain, and then you'll be able to do the sum all on your own, and that should be your basic premise. Okay children, now next we can now take this minus sign inside, and when you take this minus sign inside, again it's going to become something like what we discussed yesterday, that is something like a function a square minus x square. Now the minus sign getting inside, minus minus will become plus for the second term, and as it's a positive term we can keep it to be first, and thus we have minus a upon 2 whole square, which can be the first term, and then from that is subtracted, as this minus sign children is going to get multiplied within to give the first term now a negative sign. As such, you will now have minus times of x minus a upon 2 whole square. Right? Now that is how this, which is looking a little complicated, a little not in the form of root of a square minus x square, has actually got converted in the form of a square minus x square. Now here I will make a brief change so that we can understand this a little better, because if you make that change, there is no problem. So what is that change, children? Here we will have a upon 2 whole square in place of minus a upon 2, because minus into minus is eventually going to become equal to plus. So why unnecessarily carry that minus sign? Now the second term is minus times of x minus a upon 2, and children, there's a whole square of this, and then what we have is we have a dx. Now just one small substitution and your task is done. So what is that substitution? We are now going to assume, yes Abhinav, can you tell me? No. What we do is, there is a very simple substitution that we can do. We can just write x minus a upon 2, right? And we can take this to be, say, some variable t. Now you will say that, why is it that, sir, that you always take t? Because this is conventional. You normally start with t, then you go u, v, and so on, right? Okay, so we've taken this as the substitution, and therefore in the next step what you can do is, where there is x minus a upon 2, you can substitute it to be t. As such, within the root now you will have a upon 2 whole square minus t square. But as all of this is in the form of x, and now when we get in the form of t, the differential coefficient should also be in the form of t, that is dt. And thus now what you'll be doing is, you'll be differentiating the above equation. Right? And children, when you differentiate the above equation, what we are going to get is, we will now get the derivative of x, which will become equal to 1, right? And to that then you will be adding a 0, because the derivative of a constant minus a upon 2 is going to become equal to 0. And then further after that, we will now have on the right hand side dt upon dx, because we are differentiating with respect to x, and t is also a variable in terms of x. So now children, after this what we do is, we can just cross multiply the differential coefficient of x, that is dx, to the left hand side, and we'll have dx to be equal to dt. Right, now this is going to be substituted above. As such, now the integral that we had is going to become one of the simplest things that you've ever seen, right? So it's going to become equal to a upon 2 whole square, from which you will be subtracting. Now in place of x minus a upon 2, you will have t, so minus t square, and you can easily write the value of dx to be equal to dt, which has been just found out. Now this is just cakewalk, right? So now what you do is, you just apply the formula, but obviously before applying the formula, we will also be writing what the formula is. That is, now you're going to tell that along with me, because you learned it well, right? And if you haven't learned, please learn it. When the formula are given, this is the time to learn it, right? Because by a human's nature, even the best of the brains tend to forget. In 24 hours is something like 85% of what they've studied in that single day, and the only way that you can retain it is by revision. Okay, now children, here we had the formula that I was talking about, that is root of a square minus x square dx, right? If this is to be integrated, then this actually gives you x upon 2 times the function, that is a square minus x square, and to that children is added a square upon 2, right, times of sine inverse of x upon a, to which the constant of integration c is added. Now next children, we will be applying this formula to the given function. As such, our final answer is going to come to be x upon 2. Obviously here in place of x we have t, so t upon 2 times of, we have the function, which is a upon 2 whole square, from which t square is subtracted, right? And now to it is going to be added a square upon 2, that is a upon 2 whole square, which is divided by 2, right? And which is further to be multiplied with sine inverse of x upon a. Now here in place of x we have t, right? And it will be divided by the a. And what is the a here? The a is a upon 2, right? And now here to this we will be adding the flowers, right, for the dead constants which have passed away in the battle of differentiation. Okay, now children, next what we do is we now substitute the value of t. Remember what the value of t was. It was x minus a upon 2, right? So you will say substituting t, right, and we have the value ready, so that becomes x minus a upon 2, right? And that, children, was what? Was the value of t, right? And now here we have t upon 2, so this is going to be divided by 2, right? And further then, children, we'll be talking about again keeping the value of t. So we have a upon 2 whole square, which has to be written first, and from that is to be subtracted t square. Now t is what? X minus a upon 2, and then we have a whole square of this. Okay, and then further we have the next term, which is what? Plus a upon 2, right? So we can write this to be a square upon 4, and as this 2 is in the denominator of the denominator, so when we reciprocate, it's going to become a square upon 4 divided by 2, so that will become 1 upon 2. So as such, this 2 is going to be multiplied with this 4 to make it a square upon 8, and further then we will have here sine inverse of t, which is x minus a upon 2, right? And further this is divided by a upon 2. Now some people make a mistake of trying to take this a upon 2 outside the sine inverse. You can't take constants out of the sine inverse function, because this is a sine inverse function, and what is within is actually a value, right? And the sine inverse process, or the sine inverse phenomena, is happening within. So these values which are within, they are just not like the earlier values that we have, right? So you actually can't take them outside. Okay, now next, sometimes some children do these mistakes pretty innocently, and then you have to make them understand. Okay, here children, when we take an LCM, just to simplify this a little more, so we'll have 2x minus a, right? And as the LCM will be 2, it will also be multiplied with the 2 which is there in the denominator, and thus here we will be able to get to 4 in the denominator. Okay, now next after this we have this root entity, which I do not want to further simplify. Let this remain to be as it is, that is a upon 2 whole square, right? And further you have minus x minus a upon 2 whole square. Let it remain to be as it is, right? We don't require to do too much of simplification, because that is only required when you have to bring a result which is to be proved, right? Okay, so to this now is added a square upon 8, right, and is multiplied with sine inverse of, again here we can do the simplification a little, that is 2x minus a, and it is going to be divided by 2 as the LCM, and then further we have a upon 2 in the denominator. So this 2, as it is in the denominator of the denominator, is going to reciprocate and come above, I'm sorry, right? And 2 and 2 will get cancelled. As such, a will only be left out in the denominator. So we will now have 2x minus a, which is going to be divided by a, right, to be now the fraction whose sine inverse we are trying to find out. And don't forget the flowers, right? We will write the constant of integration at the end of this, right, which will be for the constants which we cannot get back by the process of integration. So this is all. Are you clear? Should I move ahead without giving you a second explanation? Okay, I find a lot of worried faces, and I know this, that John, right, and others obviously do require a second explanation, and with that then everything is going to become clear, right? So children, here, as you remember, we were discussing a sum on this formula, right? We derived it the last turn like this, and then after that we had to do a sum today, like I told you. So this sum was shown to you yesterday, right? So the sincere children must have written the sum and given it a try. If you've done so, please do respond in the comments and do write that, sir, I did try, and what you did is to be posted in the Google Classroom link, which is there in the description. Right, there is a separate page for you people of class 12, which is all about integration, which is being held. Right, if you are sincere participants on that page, in times to come I'm going to get back to you and I'm going to give you more stuff, right, which will further make you really strong. Okay, so make sure to get to that Google Classroom link. There's a page for class 12. In it there'll be work that we've done and also the practice questions. Do it and post your work there itself as a pic. And secondly, there's another thing that you can do, that is you have the work in front of you, right? And as such, keeping the work in front of you, you can make a short video, right, telling what actually you've done, right? And when you make this short video, see to it that you're holding your mobile straight, that is in the 9:16. That means 9 should be the length and 16 should be the breadth, right? As such, then you can post it to Instagram, you can post it to Facebook, you can post it to YouTube, and now you will have your own shots running. Might be tomorrow, because of this you become really powerful, capable, and financially successful, right? Moreover, there's another gift that I have for you people, that is, in this lecture, if there are certain parts which you find are clippable, do clip them, give them your spice, make it a shot of your own, right, where actually I am doing all the hard work and you're just throwing around a little bit of spices, but this curry that is being made, it is actually yours. So if you're able to make it viral by sharing the here, there and everywhere, you will find that tomorrow you can probably have a lot of bank balance just because of this. Okay, so now children, we get ahead and we discuss the sum for the second time, and when we end I'm going to tell you something really interesting, so do wait for it, right? So here children, what we have is, we have integral of root of ax minus x squared dx, which is to be integrated. Now in order to integrate this, what do we do is we first take the minus sign common outside within the root, right, so that the quadratic term becomes positive, and as you've seen, using it we will try and make a perfect square of this variable x. So further here, when this minus sign is taken outside, we will now have here x whole square plus the 2ab term is required, so plus 2 times of a is what? X, right? And then b is to be what? B is to be minus a for sure, because minus a here is not here, and then further it is also to be divided by 2, so that 2 gets cancelled, so you will get minus ax, right? As such, with this you will get the value of b, that is minus a upon 2. Obviously next should be plus b square, that's why you will have plus minus a upon 2 whole square, right? And that actually is your plus b square, but this wasn't there earlier. As such, you also require to subtract it, and that's why, yeah, now I find a real pleasant expression in John's face. So now you're getting things clearly, right? Yeah, I know there are a little bit of clouds which left remained in the first explanation, because that is the time when I am focusing on you people less, I'm focusing on the sum at hand more, right? And during the second explanation, I read your facial expressions, I read what you're wanting to say, there's certain doubts also I pick up, and moreover I try and explain all of this in more detail. If there are certain formulae which I've missed to share it with you, which were applied at that point, they are also written, so the understanding is pretty wholesome. Now children, after this we have minus b square, as here we have our b. Now both of these will get cancelled, as such the whole thing will come back, and thus there is no problem with what we've done. Now here children, I will make a small change. I will actually bring up the curly bracket here, because we'll be using the simple bracket inside, and as such there's no point of using the same type of bracket for a second time. These are good habits which you people can also start inculcating. Now children, after this we get to see quickly, a plus b whole square, which probably you study in class 7, is a square plus b square plus 2ab. And you also have applied it an innumerable number of times, right? So this is integral of root of minus times of. Now the first three terms can be written actually the square of this binomial, right? That is x minus a upon 2 whole square, right? And from that is to be subtracted this constant, that is minus times of minus a upon 2 whole square. Now remember children, we already had a minus sign waiting outside, so as such when we multiply this minus sign within, then the quadratic term will now have, the term with x, the variable, will have now the minus sign, and the term which is the constant term will now actually have the positive sign, because minus minus will make it plus. So we'll have minus a upon 2 whole square minus times of, when minus gets multiplied within, x minus a upon 2 whole square. Now children, here we get to see that we have this minus a upon 2, and if squared, it's going to become equal to a square upon 4. And the same is if we keep this to be a upon 2 whole square, then 2 we are going to get a square upon 4. So why unnecessarily maintain this minus sign? So we will actually shun it off, right? And thus we have a upon 2 whole square minus x minus a upon 2 whole square. Now next what we do is we will consider this x minus a upon 2 to be, say, some variable t, and then when we differentiate it, we will get the derivative of x with respect to x to be 1. Of the constant, it will be 0, as such minus 0, and that won't make a difference because 0 is additive identity. And then the derivative of t, which will become equal to dt upon dx. Now we can transpose dx to the left hand side, thus dx will become equal to dt. Next children, what we can do is we can now write all of this in terms of t. So we have integral of root of a upon 2 whole square minus, in place of all of this, just t, in place of dx, now we have dt. All right, so this becomes a very simple integral, the type that we've done yesterday, right? So we quickly write the formula. Integral of root of a square minus x square dx is equal to x upon 2 times of the function, that is root of a square minus x square, plus a square upon 2 times of sine inverse of x upon a plus c. Now this, within the last 2 days, we have repeated this probably some 5-6 times at least. So I'm sure if you are doing it every time, applying your brain there, because if you want, you can keep looking and also focus. But there's also a possibility that you can look towards something, a process, a person, but you can be thinking about something else. So you got to stop doing this. Whatever you're doing at a specific time, you should just be doing that, right? So don't just look at the screen, but also focus and participate. So here, when you're focusing and participating children, then as we repeated this some 6-7 times, so I'm sure this must be very, very, very well learned. And already I've told this to you people to write this at least twice or thrice. Once when we did the short, second time when we did the long. For the derivation, I asked you people to do it again. So obviously you did the class work done again, as I call it. And then today too, while applying, you must have written this formula, right? And now you will again write it. So thus we are able to learn, write, right? That is learn, do, and tomorrow you can even teach it to your friends, right? And if you can get a small group of children to which you can teach something even tomorrow, right? So that can be your side hustle. Okay, so getting that side hustle, that will be something just like ice cream money, or probably you can accumulate some amount of money to gift to your parents on their wedding anniversary, something really special, right? And you can do n number of things. Okay, so next now children, what we have is we have this now. Now after this, we have applied just this formula. So in place of a here, we have a upon 2, and that we'll keep, right? And in place of x, we have t here, so as such we'll have t upon 2. Here too we have a square upon 2, and because a here is a upon 2, so it will be a upon 2 whole square divided by 2, and then we have sine inverse of, in place of x, t divided by a, which is a upon 2. Next then what we do is we just substitute the value of x, which t, which is x minus a upon 2, right, at the proper places. There are certain LCMs etc that we've got to take, and we try and simplify this, and then we get to our final answer. All of this simplification I'm sure you can do, right? With even your left hand if you're a right hander. It's so simple. So I think all of this is perfectly clear. Sure. John, Megha, very good. I can see pleasant expressions on your faces. That is because you haven't picked up your pen till the time I have completed now the second explanation. So from the time that I'm explaining for the first time, doing it with you, and also explaining and then explaining it for the second time, please don't pick up your pen, please don't pick up your book, please don't pick anything else up. That is the time when you just require to look up at the board exactly where the teacher is. So if suppose the teacher is at -a/2, you require to be here, right? If your focus is intact, right, and if you keep listening to what I'm telling you as it is, nobody can stop you from becoming an expert, right? And tomorrow you can become a very successful mathematics teachers. That is where my mission comes in. My mission is actually not just to teach children mathematics, but also to make 1,000,000 teachers of mathematics who can spread the knowledge of mathematics just like petals of flowers, and they then will bring in such good order in the world that everybody probably will be capable in mathematics, and as such capable in logic, and they will be able to take better decisions and live better lives. Isn't this a good idea? Are you part of my dream? If you are, make sure you fill up the Google form link which is there in the description of my YouTube video channel, right? And you will find that whatever problem you have, or you want to fast track your journey and you want to learn quickly, or probably you want to learn some other topic, or you're part of my mission, you want to become a teacher of mathematics, sit at home and earn lots, right? So fill up that form, tell me, I will get to you and I'll put you in that proper pathway. Okay, now something interesting which I was planning to tell you today, because today is the 23rd of October, right? Today is the day when one of my special friends has a birthday, right? So I wish Sourobh a very happy birthday. Except that today is the International Day of the Snow Leopard, right? Then today is also celebrated as the Mole Day. Now when we talk about a mole, don't think about a mole that you have on your face. I have a mole just in this portion of my chin, that is in my beard, and that is why it is understood that I'm a very powerful person, which actually I am, right? But if you remember the mole, there's another meaning. That is, if there's some, say, team and there's a mole in the team, you know that that is the person who's leaking all the information. But there's also a third mole. What is that? That is actually the amount of a substance. Remember, we had SI units, and in it the 7th was the amount of substance, which is a mole, right? A mole had a definition. That means at standard temperature pressure, if you talk about the number of particles, right, which are there of a substance, it will be 6.022 into 10 to the power 23 particles, be it atoms, be it molecules, be it ions, whatever. Now this is why today, the 23rd of October, right, from 6:02 a.m. to 6:02 p.m., right, now 10 raised to the power 23, that's why 10th of October, the 10 raised to the 23, that's why 23rd of October, month 10, right, is celebrated as the World Mole Day, recognizing how important the mole or this SI unit was. Okay, so all of this is something which is related to this day, right? I hope all of this you people must have enjoyed, and you're getting to know not just maths but also new things and new ways of doing things. So pick yourself up, do some good work, and show to the world this is what I am, right? You have a play card in your hand, and this is the time to make your play card. Make your shots, post it to me by just doing what is that known as @the mathematics helpline. You require to tag me at this @the mathematics helpline. So I will get your shots and then I'll evaluate your shots, and in a month the top 3 people who made the best shots, I'm going to give you gifts which will reach you at your homes, right? So pick up this competition, do it, and in this world, we all together, we'll make this a mathematical one where everybody will have mathematical sense. Bye children, this is Sourobh Kumar Dotto signing off, and I think that I'm able to make a difference, and if so, please drop a small comment, right, so that I can continue this activity, right, of bringing in some positivity in society, right. Further, if obviously you've been through till this time, right, and there are gifts which are lined up, right, just fill up the form which I told you, the Google form, and I'll give you some gifts, right. Moreover, there is obviously, if you like this thing, put up a like. If you dislike this, then obviously you can put up a thumbs down, and do write what all you learned, right, and you'll find a lot of links which will be there in the description which are of your use, and except that, there'll also be a pinned comment where you will get a lot of essential links. Okay, bye children, have a nice time and enjoy your lives. Bye.